your homework, if you're just coming in right now, please grab a lesson and take your seat quietly. You're late. Yesterday in your homework, you guys had to do a question. Shh. You guys had to do a question regarding simple interest. Does everyone remember that question? If you guys still have phones out or headphones in, let's get those away, please. Okay. So simple interest. Yesterday we talked about what we call compound interest. Now, okay, so yesterday, I'm just going to wait until everybody's ready here. Okay, yesterday we learned about compound interest. Can somebody explain to me what it means to compound and why compound interest, like what it's all about? Sebastian? Perfect. So I like the word stack, that's kind of cool. So we have our principal amount, and then we're going to earn some interest on that. And then the next time we start to earn interest, we're earning interest on the principal amount and that previous interest. So we get some new interest on there. So it kind of becomes a stack, right? We get interest on previous interest, and then interest on that previous interest, and then interest on all that previous interest, and so on. Now, simple interest, you are only ever earning interest on the principal value. So you don't get to earn interest on previous interest. So with simple interest, we earn, maybe I'll need to use my stylus while the video is recording. You will only earn interest on previous interest, or sorry, on the principal amount, not on previous interest. The simple interest formula also does something a little bit different than what the compound interest formula does. The compound interest formula will give us out the total amount that we have. So it will tell us if I invest $2,000, it will give us back maybe like $2,400. The $2,000 was mine originally. The $400 was the interest part of that. So the simple interest formula actually only gives us out interest. It doesn't add the principal value to that interest. So if I invest $500 and I get out from that interest formula 10, I actually have $510 total. Right. So the formula for this only gives the final amount of interest earned or owed, not added to the principal amount, whereas compound interest gives us the whole total. Okay, so if I'm earning 5% interest, let's say I invest $100 each year. Let's say let's say the interest is earned yearly. Each year, what is 5% of 100? 5% of $100. $5. You got there eventually. You just kept throwing out guesses. So 5% of $100 is $5, right? So if I'm earning simple interest on $100, I'm just earning $5 each year. So the first year after the first year I have 105. After the next year I have 110. After the third year I have 115. So I'm only earning 5% on that $100 each year. That's the idea. Okay, so I is interest earned / owed, depending on the scenario. P is still the principal amount, so the initial investment or the loan or whatever. R is kind of like our I in our compound interest formula. It's interest rate as a decimal. I think the question that you guys did last night introduced you to this, but we'll just make sure we have it in our notes formally. And T is time in years. Always. So if you get months, you need to switch it to years.
What if it's not a whole year?
Then it will be like 0.5 or or 1/3 of a year, right? 4 months is 1/3 of a year.
Yeah, that's just rough.
I know, life is hard, right?
I know.
Especially in grade time.
It really is.
Good, can I scroll?
Just having a real, like, job.
We're okay? Okay,
Oh my god.
so we're gonna talk about simple interest here. Karen, you ready?
No.
Make yourself ready then. Okay, how much interest is earned if $1,200 is invested at 5% per year, simple interest for 3 years? So you're either going to see compound interest or you'll see compounded, the word compounded, or you will see the word the simple interest in there somewhere so that you know which one we're dealing with. Either it's compound interest or it's simple interest. So this one is going to be simple interest, telling me we're using the I equals PRT formula that I just showed to you above for 3 years. So principal amount that we put in is $12,000, or $1,200, I should say. R, interest rate as a decimal, 0.05. T, time in years. And the final interest value is I, and that's what we're looking for. So we're going to plug into our I equals PRT formula. This should be a really easy, straightforward. Yeah, that's right. It's easy. Okay, and then just multiply. What did you guys get? 180. This is dollars. Okay, so how much total money do we have now? What is it?
About 1,380.
Right, so the compound interest formula would usually give us out that total amount, whereas this one just tells us this is the interest that we earned, and then of course we still have that original $1,200. Okay, part B asks about the scenario that actually Karen just asked me about, which is how much would you earn in 4 months? Keeping in mind that we need T in years. The only thing that changes here, P and R are the same, but T is going to be, I can switch this into years by dividing 12 months, so it's like 4 months. And then I can divide by 12 months to get the decimal value or the like fraction value of the year. So I would actually just enter this in rather than finding a decimal. Let's just enter it in as 1/3. Okay, that 4 months is 1/3 of a year, right? One third of a year. So we're going to enter in our 1,200, our 0.05, and then we'll multiply that by 1/3.
What's the test?
I think it is 2 Wednesdays from now, I want to say. It's either like the Tuesday or the Wednesday. I think it might be the Tuesday, actually, of the, not next week, but the following week. Okay, this one might give us some decimals, so we'll just round to 2 decimals for money. What did you guys get? 20? Exactly? Oh, perfect. So no decimals. $20. So total after 4 months is 1,220, I should say. Not too bad? Okay. Any questions for this one? Okay. All right, so the graph that you see here is showing the graph of simple interest. So you should notice here that if you remember back to our compound interest chats and homework questions, our compound interest is actually an exponential relation. It looks like kind of like a curved graph, or it should at least if you have graphed it properly. What do you notice about the function here that we see on this graph for simple interest? Sam?
Exponential.
It's not exponential. What is it? It's actually linear, yeah. And that's because with simple interest, we're always increasing by the same amount every time. It's like plus $5, plus $5, plus $5, plus $5, and so on. Okay, so can somebody tell me, just by looking at this graph here, what is our principal value? What's the initially invested value here? Sam?
$800.
800. I'm looking at a time of 0. That's the starting value, right? So our principal value is $800. What is the annual interest rate? Okay. So if we look at this, in 10 years, I can see I have $1,200. So I need to figure out so how much have I earned from 800 to 1,200? We've earned $400 over 10 years. And I want to know how much we earn in 1 year.
That makes it, I don't know, is it 40?
Yeah, $40 per year.
Yeah, that's pretty.
Lovely. Awesome. Now we're going to write an equation to relate the amount of investment to time. So our starting value, this is kind of like our B value. So I want us to think about the equation in terms of a line, y equals mx plus b. Okay, this is a linear function, agreed? The y-intercept is b. So what's our y-intercept? 800, okay, plus 800. What is the slope of this line? How is the line changing? 40, yep. So it's 40 per year plus that initial $800. Okay, so if we think of this in terms of our actual variables here, maybe we'll have y be our amount and x be our time in years. So maybe we can say it like this.
Or B, do you have to write the interest rate as a percent?
B, like annual interest rate? Oh yeah, I guess we need to think about the percent there, right? Yeah, so we didn't go quite far enough with this one. Yeah, thanks, Ivana. So $40 per year. How do I make this as a percent interest rate? So what percent of 800 is 40, right? So if I want to know if I got 70 out of 80 on an assignment, let's say, if I want to figure out my percent, I will divide those things, right? And then I will move the decimal. So what did you get? Okay, so you got 0.05 from this one, which gives us 5% per year interest rate. Good? Any questions? Okay. So that's simple interest. Just as a reminder, we talked about compound interest before. Compound interest has a couple differences from simple interest. Firstly, compound interest, yep,
For the last question, what's the answer for C then?
this that I boxed here.
Oh, so
Okay.
5% didn't matter?
The 5% is represented by the $40 per year. Okay, if I calculated an I equals PRT, I would need the 5%.
But we aren't.
Right, we're just creating an equation of the line that we see.
Why did we do it then?
Because it asked us to.
Yeah.
Where?
What is the annual interest rate? It's a rate.
Where's, oh, that was B.
Yeah.
No, this is why I'm not taking this. I didn't think I had to do this.
All right, moving forward. Compound interest. So the differences here, Maureen, can you put your phone away, please? The differences here are that compound interest, you get to earn interest on previously earned interest as well as the principal amount. Okay, just as a little side note here, when I say the word compounded, I mean that's when the interest gets added to the principal amount. Okay, and the other big difference between what the formula that we were just working with the I equals PRT, is that, like we said, the compound interest formula gives us out the total amount that is owed or earned in that particular investment or account or whatever. So the formula gives the final value of the principal amount plus all of the interest. Whereas simple interest only gives us the interest earned or owed. So our compound interest formula also adds the principal amount to that value. Okay, so just to remind you guys, we were dealing with the formula AP. You can do 1 plus I plus 1, whatever. Usually we do 1 plus I. This one's reverse, which is okay. And then N. So we talked about how A, capital A in this case, not to be confused with lowercase a from our y equals A times B to the exponent x. This is our future value, just as a little recap. This is our principal or initial value, or amount. This one's going to be important for today. So yesterday we only did examples with compounded interest annually. I is going to be the interest rate as a decimal. And then we need to divide it over the number of compounds per year. Okay, so annually is 1. But if we have anything other than annually, I will need to divide that by whatever the number of total compounds are per year. Okay, and then same idea with N. N yesterday was just equal to number of years because we didn't deal with various compounding periods. But today we are going to deal with various ones. So just as a reminder, N is going to be number of compounds per year. So this number in the I and the N will be the same. This number of compounds per year times number of years. So really what I want to know for my N value here, when I calculate N, I want to know what is the total number of compounds in my given time. So if I compound twice a year for 4 years, how many times would I have compounded my interest? I'll say it one more time. If I compound twice a year for 4 years, how many total times? 8. Good. Okay, there we go. I knew you guys would get there. Okay.
Kinda slow.
Still not quite there yet.
Yeah, it's okay. It's Friday.
Can you go back up for a second?
Yep.
Some of us are slow with that.
What am I talking about me?
I'm good.
He's talking about writing, Ivana.
Yeah, okay.
Okay, so a couple things that we're going to be looking for in these types of questions are the variety of compounding periods. So we already know we worked with compounded annually. How many times a year is this?
Once.
Once a year. 1 time per year. Okay, semi-annually. Any guesses? Yes.
I know my stuff. Maybe I should
Quarterly.
4.
4 times per year.
Literally, the reason I didn't take business so we didn't have to do this, and look at me doing it.
Weekly.
Once a week.
Once a week, yes, for the whole year. How many times a year? 52 times per year.
How did you know that?
52 weeks in a year.
I've never heard anyone say that.
Bi-weekly.
26.
Yes, so bi-weekly is not twice a week, it's every other week, right? So this is 26.
How many times you get paid?
Yes.
How many times I get paid a year?
Yeah, just think about it, you're doing the math, and you pay.
I'm not
Okay,
paid.
let's say you happen to see daily. What would daily be?
365.
365.
What's 366?
We'll keep a standard of 365.
When's the next like leap year thing? Next year. Next year? We have an extra day next year? 2020's got an extra day. Wow.
Cool.
Do you guys remember the day that it was like when 12, 12, 12?
No.
The date was, you guys don't remember the date it was? The date was 12, 12, 12?
No,
December 12 was 12.
no, nobody remembers that character.
No one remembers that. I remember I was writing it in math class and I was like, oh my gosh, it's 12, 12.
It sounds like something you would say.
Yeah, I don't know, I remember it so well. I think I was in like grade 4.
Okay, do we need a break or do we want to finish? This is the last thing.
Yeah.
Okay. Okay.
We don't have a
So focus, Karen. Focus, focus. Okay, so Mark, he's going to borrow $7,000 from the bank for a new car. He plans to repay it over 7 years. The bank charges 6.9% interest per year, compounded annually. Okay, this is what we did yesterday, right? Compounded annually. So,
Charges 6.9 interest.
okay, so when you want to go buy something, like a house or a car, if you don't have the cash up front, how do you think you get that car?
You ask your mom.
No, you don't ask your mom. You will go to the bank or at the car dealership. They will put through the financing for you, but it's to banks. And then the banks will come back with a competitive interest rate that they will offer you for this loan. And this interest rate is based on how good your credit is, based on your previous payments on, let's say, if you had a credit card or if you have any kind of thing that's somehow attached to your name, right, that they can kind of do a credit check with. So they will come up with some kind of rate, and the bank isn't giving you that $7,000 for free, right? Because what do they get out of it? What do they get out of giving you $7,000? Well, they get extra money back because you pay that $7,000 back, but you also pay interest on that.
Oh,
Right?
So you'll be paying back more than $7,000?
Oh, yeah. Yeah. Okay, and you can imagine if you're having to pay back interest on a mortgage, you pay lots of extra money. Okay?
So they're paying 6.9, like more than $7,000?
And it's compounded, so they have to pay interest on previously incurred interest.
Oh my god.
I know.
Ask your mom.
No, that is not the solution. Okay, so principal value is our $7,000.
Don't buy a car.
I, interest rate as a decimal, divided by number of compounds per year. How many compounds per year do we have in the first scenario?
Annually, once a year.
Okay, so we'll just get back 0.069 for that one. Okay, we're going to repay it over 7 years. So in 7 years, if I compound the interest once a year, how many times have I compounded the interest at the 7 years?
7.
7 times, thank you. Okay, and we want to know what is the amount we must repay to the bank. Now, just so you guys know, usually people make regular payments, so this isn't quite exactly how the interest is calculated. It's calculated in through what we call an annuity. That's when like regular payments are being made, like a mortgage or a car payment. So this isn't exactly a perfect real life scenario, but it gives us an idea of kind of what happens. Elise?
Is the one always underneath?
Depends on how often we compound. So you're going to see in this example that we are going to change the I once we change how often it's compounded.
So if it was like compound, yeah, like 2 5 5.
Yeah, and I would multiply my n by 365 as well. Okay, so we're going to plug in here. We'll get 7,000 times 1 plus 0.069 to the exponent 7. What'd you guys get?
12,167.
Okay, so he must repay $11,167.14. So he pays back the $7,000 plus how much interest does he actually pay back?
No, I don't know.
No, not 167. It's
Oh, yeah.
$4,167 extra that he has to pay.
I am not excited to be an adult.
So if he pays back $11,000, the $7,000 is how much, of course, he has to pay that back, but anything extra on top of that was interest, right? So we're just taking that $11,000 and we're subtracting the $7,000 from the initial loan to get the interest that he has to pay back. Okay? So total, he pays back $11,000. Of that, $4,167 is interest that he pays. $7,000 of that is the initial loan. I know. Okay, suppose this were simple interest. If we were doing I equals PRT, let's see how much he would have to pay back without compounding, so without having to pay interest on previous interest. So our P is still going to be 7,000. Our R is our interest rate as a decimal, and our T is time in years, so 7 years. So when we calculate I equals PRT, Karen, focus. Alex?
So like, you know when like you go into like a commercial that says 0% interest?
Yep.
How does that work?
Yeah, so sometimes people will like do that as an incentive for people to buy new cars because they'll say like, oh, you get 0% interest on this, which means that you're actually just paying back the amount.
You buy a car for 25 grand, you're paying 25 grand.
Yeah, but cars decrease in value. Yeah, but cars decrease in value so quickly. Like after the first year, your car is worth way less than what you bought it from the dealership.
But like it's better than doing this.
Is it?
And that.
Sometimes yes, because if you're paying a lot for the car already, and then you're having to pay, so if it's a used car, usually you have to pay the interest on it. If it's a new car, usually they'll offer incentives so that people will buy the new cars. But it's actually much more cost efficient usually if you have the money, or some of the money at least, it's usually much more cost efficient for you to buy a car that's like 2 years old than for you to buy a brand new car, because cars decrease in value so quickly. So yeah, good
What about
question.
a 2-year-old car?
Yeah, rather than a new one, because the value is like you'll pay way less.
Already down?
Yeah, but you'll pay way less than buying a new car,
What happens
right?
when you want to sell it? You have like 2 values of it?
Karen, you lose
Pretty
money,
much.
That's how it works.
What did you guys get for simple interest here?
Yeah, 3,300,
389?
381.
Oh, exactly? No cents?
Sam, your calculator doesn't do it.
Okay, so this is the interest. What is the total amount to be repaid?
10,000.
Okay. So he has to pay the $7,000. Shh, focus in here, guys. He has to pay the $7,000 plus the $3,000 in interest. It was no cents, really? Yeah? Okay. Just checking. Okay, so it makes a big difference. I think the conclusion we can make from part A to part B is it makes a big difference if there is interest being incurred on previously owed interest, right? Versus if you're just doing simple interest and it's only on the principal value, that makes a large difference in the amount that we have to pay back, right? It's about like $1,000, well, less than 1,000, about $800. Okay, now I want to take a look at the impact of what happens when we compound interest semi-annually and monthly, and we're going to compare that to our annual interest. Okay, so semi-annually, oh, I don't have that much space on here. Semi-annually for Part C, we're going to do these both kind of at the same time, and then monthly. So semi-annually, remind me how many times a year is this? 2 times per year. And monthly? 12 times per year. Okay, this is my number of compounds per year. This is what I was talking about in that earlier formula. Okay, so the principal value is still 7,000 for both of these. That doesn't change. Maybe I'll zoom in on this a little bit for you guys. Okay, my I, interest rate as a decimal, divided by number of compounds per year. In this case, it's divided by 2 compounds per year. Okay, so here's the idea. I take, let's just use 6 as just a more basic example. If I have 6% interest, but it's compounded semi-annually, oh, what am I doing? 6% interest, and I have 6 months, and then my next 6 months, I don't earn 6% and 6%. I need to break up the amount of interest so that it totals 6% evenly. So how much do I earn at the end of the first 6 months? 3%. And then at the end of the next 6 months, I earn that second 3%. So that's why I'm dividing this by 2, right? Because I have 2 compounds, and I want to split it up evenly over those 2 compounds, okay? So what do we get here? It's 0.0345. Okay? This guy over here, when I calculate I, this guy's going to be divided by 12. Okay, because it's 12 compounds per year. So I want to split my 6.9% into 12 equal little interest slices that I earn each month. So my 0.69 divided by 12. If you want, you can leave this as a fraction. But if we divide it, what do we get?
0.005.
Okay, great. Okay, and then the ends will change here as well if the number of compounds per year changes. So if I compound twice a year for 7 years, how many times have I compounded my interest total? 14. So I do 7 years times 2 compounds per year to get 14. And then I find my amount, right? For this guy, if I compound once a month for 7 years, 12 times a year for 7 years, I want to do 12 times 7 to find the total number of times I've compounded my interest at the end of that. So, what'd you get? 84, yeah. Okay, and my future amount is the question mark here too. So we're going to see the impact on what happens the more frequently I compound the interest. So we're going to calculate each of these. And we're just going to sub in what we have up here. Does anyone have an answer for the first one here for us? Sorry, what was it? 11,284? 54? 24 cents? Okay, and what is the interest owed?
46 cents.
47.
Oh, 47 cents? What was it? 0.4, yeah, so 47.
I thought it would, because, oh, okay, never mind.
Because yesterday you told us, like,
I thought it was cents.
So, well, if it's money, usually money gets rounded up, right? So they're not gonna lose out on even 0.01 of a cent. Yep, yep, for sure. So how much interest did he pay in this scenario? He paid back the 7,000, and then anything extra on that is interest, right? So what's 11,254.47 cents minus 7,000? It's 4,000 and 47 cents. So the $4,254 of that is the interest part. Okay, has anybody calculated our second part for us here, the monthly part?
No.
Sebastian, what'd you get? Exactly? 82 cents? Okay. So how much interest did he pay in this scenario? Mm-hmm. Okay. So can somebody tell me what the impact is of compounding the interest more frequently? You owe more. Or if you're investing, it's in your favor, right? Because you get more. Or in the bank's case, they get more, so it's in their favor to compound that interest more frequently. I mean, you don't really have a choice when the bank loans you money. But yeah, so I can't remember what the certain formulas are exactly, but it's a little bit different than this because you're making regular payments as well. But yeah, the more often you compound interest or you add the interest on into smaller amounts, the more interest is going to be there at the end, right? So when we compare to annually he only had to pay back $4,167. And then semi-annually, it was about $100 more. And then monthly, it was that much more again. It was like $200 more than annually. So more frequent compounding, the more interest there is. Because more interest gets earned on previous interest.
I don't like this.
Yep, there you go. You get some life understanding.